Can you see my screen?
Yes, I do.
Okay, perfect. Well, welcome everybody. Good morning. My name is Spencer Waite. I am a computer science major student at the University of the District of Columbia. My senior project is adaptive video game AI, and I'm using the Unreal Engine 4 game development engine. Let's see. There we go. The outline that I'll be talking about today, I'll begin with my abstract and the purpose of my project. And I'll move into some research that I did to help me sort of determine what I wanted to do and how I wanted to do it, show a little bit of previous work that had been done on this topic. And then I'll show you the outline of all the tasks that I figured were required in order to do this. I'll show you along the lines all of the progression achievements that I made along the way, how those turned out and what they look like. I've got a couple deviations from the original plan that I'll discuss, and then I'll show you a screen capture of basically everything combined, the complete project. And I've got my resources citations. I'll see if there's any questions at the end. So the abstract of this project, there's the problem, essentially, the reason why I wanted to do this is that in modern video games, they usually will begin by asking the user to choose a preferred difficulty level. And in so doing, this level will generally remain the same throughout the entirety of the game. And that does not change based on if the user's skills improve or get worse. Um, those users can easily lose interest in the game if the difficulty level is not level to what their playstyle is. So if they're not good enough to go against the AI difficulty that they've chosen, or if they're a lot better than the AI and it's just a breeze, it's just not very fun, and they'll just lose interest. So the approach for this is that addressing these limitations, I wanted to propose an idea of implementing an adaptive AI that will determine the user's skill levels, and that will be like a real-time event to provide an appropriate challenge to them so that as they progress in the game and as they get better, or if they get worse, the AI difficulty will scale based on that in real time. And that will be created using the Unreal 4 game engine. And yeah, so essentially it will just continually scale based on the average statistics of the user. So a little research that I did in, so me, myself, to give you a little perspective on who I am, I do enjoy playing video games, all different sorts of games. Um, and so I had seen this as I would play. A lot of times I would just get bored of specific games, and I wouldn't want to restart and choose a different difficulty setting if it just wasn't very fun to me because it was just too easy or too hard. Um, and so this research that I did, this is talking about difficulty of AI and how things that have happened through developing specific games, how game developers choose the difficulty levels and how difficult they can be or how easy they can be. What they did in this research, this is just from Ask a Game Developer. That's what they call themselves. They don't actually give you their specific name on the site. They have these three figures that you can see on the right, and they proposed a system to create AI that was very intelligent and would do strategies of how real humans would do it. So you've got a team of bad guys. They're all hiding behind cover. The player approaches, and they start shooting at bad guys. And so then what they do is one bad guy stays behind and continues to shoot at the player to keep their focus. And two of the bad guys will run around to flank. And then all of a sudden the player is now being attacked from behind from the bad guys that you see in figure 3. So what they found doing this and testing this on a bunch of different people is that people felt like this was just unfair or that the game was broken. They didn't see the other AI going around to flank, and so they thought that the game was broken, and that the AI were just spawning behind them, and this just wasn't fun for them. And so they realized that people would just then fall back into like a choke point position to where the AI couldn't flank them, and then they would just pick them up like that, and they would just continue through the game in that manner, to where it would just make it very repetitive and really boring. So they found out that what players really want is fun AI. They don't want the AI to be too difficult, or else it becomes boring. So in AI programming, it should be focused on simplicity and not complexity. So some of the previous work that's been done, there's two articles that I found where they're going along very similar things to what I was proposing on doing. The first is an article called Adapting to Human Gameplay. And what they did here is they used a zero-sum military strategy game called Tempo, and they trained an AI to mimic the human choices in that game. And what that game is in a basic terms, you've got an enemy and you've got the player, and they make choices on how to distribute their money, whether they want to put it into offensive forces, defensive forces, or put it into the economy, or however they want to do it. And then each year that passes, there's a chance that war will break out, and then based on when war breaks out, it will just compare the forces of the enemy versus the user, and then just determine who wins. So it's a very simple game. What they tried to do is to get an AI to mimic the choices that the humans were doing. And some of the difficulties that they faced was the users are very unpredictable at the beginning because the users had never played this game before, and so they didn't have any strategy, so they just randomly tried things, and that's very difficult to mimic. Um, and then something else that would happen is the AI would rely too heavily on the previous year's strategy because they were looking backwards to figure out what they should do now. And this didn't really work in this specific type of game because the strategies a lot of times would be for the future. They would never be looking forward to say, I want to last as long as I can at year 8, but I'm only at year 2 right now. So they're doing what's best for them at the moment. So these are all things where it's very difficult to get an AI to do what the user can do because um, it runs into those sorts of roadblocks. The second one is they created an adaptive AI in a racing simulator to make it a challenging and fun environment for basically any user. And they were just talking about how racing simulators, which I love doing racing simulators. This image on the right, this is from Gran Turismo Sport. This is one of my favorites. And I have actually seen this. This is what drew me to this in particular was um, the AI that you face. A lot of times they're very predictable because after just a couple of laps, and a lot of races you do many laps, they make the same decisions on every corner. They do the same thing. They have the same speed. Um, and so they're programmed to do basically one specific thing. And a lot of times you have a lot of different cars on the track at one time, and they're not all programmed the same way. Usually you'll have one that's really fast, that's your competitor. They're usually in the front. And then you have a couple that are programmed to be really slow, that are back markers in the back to get in your way after you lap them. And so it's very predictable. There's not very much variety. So they wanted to make it so it's challenging, yet it's fun, and there's variability. All users can play. So that's what they ended up doing. So just moving on really quick, I've got 7 steps that I created that I realized in order to do this project, these were required. I needed to begin by just creating a basic AI prototype, which is a wandering AI. So it doesn't do anything other than just walking around. But in order to get that done, there's several components that need to be in place where those are required for basic AI up to advanced AI. Second step is basically creating a framework of this first-person shooter game that I wanted to create this AI in. And that's just an arena, a first-person viewport, and the user mechanics so that the user can move around, shoot, and do all those sorts of things. The third step is creating a damage and health system so that each character can take damage and has health to display that damage taken. The fourth step is programming that wandering AI to now be more interactive, to seek out and attack the user. After that, step 5 is creating a death and respawning system, which is based heavily on the damage and health system. So then when your health reaches 0, you will respawn somewhere in the map. And then step 6 is using and gathering the user's data and displaying that on an interface display. And that's to give you sort of the what you need for the final step, which is to take that data and to use that as training input for the AI. And I'll explain all of this as I go through. So step 1 is just the basic AI components. Creating this basic AI needs 3 specific things. The first is a behavior tree. So this is creating AI in Unreal Engine 4. The behavior tree is used to basically activate the AI, and it will run through, you see the behavior tree on the right, it'll run through this tree, and it'll start at the root, go down, and continue to follow the left to the right. And so this is just very basic from the very beginning. It has a condition of if the target actor is set, which is there like an enemy that the AI knows about? If so, move to that enemy. Use that enemy, which is just, you'll see in a second, that's it basically tagged the user, waited a couple seconds, and then went and then found a new random location, moved to it, waited, and then it would just continue in that loop. The next thing is an AI controller, which is essentially the brains of the AI. And that's where you do all the coding, and that's where you tell it how to do specific things and how to figure things out in the world. And then the blackboard is used to store all the current information that the AI is currently thinking about, what it's currently doing, and that's where all of its variables basically sit. This is just a brief basic AI controller blueprint. So in Unreal Engine 4, you can use blueprint visual scripting, which I did for most of it. You can see, let me pull this up so you can easily. So right here, you begin on perception. So it's using visual perception. When it sees something, it adds it to an array. And then in that array, it puts it into an interface, which is the usable things interface to see, can I use this? If so, it takes this target and then adds a name, a blackboard value to that target, which is essentially the enemy. And it sets that value as the enemy. And then down underneath, this is basically the tagging method that I'll show you in just right after this. It basically takes that blackboard value key, which is the enemy at this moment, just make sure that they're on the interface that was created above. It comes through, if it can be used and it is the enemy, that it will come over and use the enemy, which is just tagging it. Later on, this turns into shooting the enemy instead of just tagging. This is just the basic way of getting started. And then it clears the blackboard value here and is no longer the enemy. Essentially, they've died. Then moving on. So this is a screen capture. This is the first one that I had done. You'll see I have it in a third-person viewport. That's the AI that's walking down at the top left. He's just randomly wandering around, and he's using a navigation mesh to figure out where to go, which is that green. He finally sees me, and he's now chasing me until he finally reaches me, tags me. My value has changed, which I just have as a 1 above. Now that my value has changed, essentially I've died, then he ignores me until that value changes again, which will only happen once I get a respawning system in. So you can see his visual perception there and what he can see. At the moment, he's got a 90-degree vision radius. So then the arena that I created, I changed it from the original, what you just saw in that video. This is now just a very simple first-person shooter arena, which enables more strategic elements because you've got obstacles to use as cover. You can do more advanced maneuvering, and you've got an elevation difference to give you more sight lines. And then it's also mirrored for fairness, so that no matter what side you start on, it's the same on the other side, so that there's no advantage between users. Then I added in step 2, I've got first-person shooter updates, which I've got 3 images here. The bottom left, I guess, is the first on the list. It's a little out of order. That's the first-person shooter viewport. That's an image of you actively shooting, so that's why it's a little blurry. But you can see a shooting projectile. It's got the AI standing in front of you there, and you're in that arena. So you're aiming down the sight of the weapon there. Above, you can see the image. I added some 3D models. That's the weapon that both people are using, and then the AI model is now it's at the bottom right. So those 3D models just sort of give a better environment and give you a better feel while you're playing. So now this is the first-person shooter mechanics that I created a screen capture for right as I implemented this. I'll play this. So you're shooting this weapon, aiming down. You can move around, you can jump. Nobody takes damage anymore. He runs over, he tags me, he runs away. He doesn't really care about me anymore because, for all intents and purposes, I'm dead because he did what he was supposed to do. And then moving on, I created a damage and health system, which you can see in the screenshot. There's a health bar above the AI, and then also the top left of the user, your current damage, your health, I mean. So at this point, the AI couldn't be damaged yet, only the user could be damaged. This is just sort of incremental as that's going along. But at this point, the respawning system is not in place, and so you'll see in a screen capture that nothing would happen when your health hits 0. So I'll have a screen capture after this to show basically both of these, the health system and the interactive AI. So I programmed this AI now to not only just run around randomly, see you and move on, or see you and tag you and move on, but now this AI he sees you, and then if he loses sight of you, he doesn't still instantly know where you are, but he knows that you exist, but he knows your last known location, essentially. So he'll move to your last seen location, and from there, if he doesn't see you anymore, he will then find a search radius point within a radius of that last known location. So you can see on the right, this is another behavior tree segment, which is the condition of can you see the player, or if the player cannot be seen, then move to the last seen location, and then find a search point based on that, and then move to that search point, wait, and then continue just move through that. So the AI still remembers that you exist, but it doesn't know where you are. Now you'll see that the health system and him losing sight of you. So my health is going down at the top left as he shoots me. His is not currently going down, but that's fixed in the future. At this point in time, his turning was sort of weird. It's really jittery. He also doesn't really shoot straight at you, and he can very easily lose sight of you because I had to narrow his vision radius. And that's all later fixed. Those are just issues along the way. Now he sees me again, he's shooting me. He loses sight of me again, all that sort of stuff. So then I improved the shooting mechanics in the AI health. So instead of shooting a projectile, I then changed it to line tracing. Because if you think about shooting a weapon, it is shooting a projectile in real life, but it happens so fast to where it's essentially a laser, if you just want to think about like an imaginary laser shooting at a weapon. In such small proximity that this arena is, it's essentially like you're shooting a laser. So instead of creating the projectile and worrying about that and having it more computationally expensive creating continuous projectiles, it just basically looks at a line trace from the barrel of the weapon to a specific radius. And then I added an aim down sight mechanic, and which you can see in that image right there. So you can aim down and It gives more precision to your shots. I also changed it so the AI now takes health damage and his health decreases. And the ammo counter, I added that at the bottom right of the screen. And that basically gives you just a representation of how much ammo you have in your magazine and how much you have in reserve. So then with the spawning system, this is essentially, you're looking down on the map. You're looking down on the map of the arena. And to begin with, I just had spawn points, respawn points, where the red circles were. Top right was where the AI would respawn. The bottom left was where the user would respawn when they died, which you'll see that in the screen capture coming up. And I later changed that to where then, instead of just having a predictable respawn point, which was just unfair, I changed it to have it in any random area in this arena, which is anywhere where the green is, which is, that green is the navigation mesh that the AI uses to know how to navigate and where it can go. So at this point, both the user and the AI can both take damage. And so you'll see here the respawning system is in place, and both can take damage, and they'll just respawn back at that set respawn point. And there's also the aim down sight mechanic, so you can aim down the weapon, shoot while aimed down sight. And the AI is just running around randomly. So now he sees me and he's shooting at me. My health is decreasing. He is too. I'll kill him here, and he goes back to his original spawn point with full health. He kills me, and I go back to my original spawn point. So that's where I was in that stage. Now, step 6 and 7, these I did simultaneously because they're linked very closely hand in hand. This is creating a calculator for the shooting accuracy of the user, which is essentially determining how many shots has the user taken versus how many shots has the user actually hit on target. That will determine the accuracy of the user. And this image right here is just showing your current accuracy, or the user's accuracy, and the AI's accuracy. And this will be positioned at the top right of the viewport of the user. And this gives you just an easy, out of the corner of your eye, you can see these sort of progress bars that will change based on the accuracy to give you a very easy sight of how yours compares to theirs. And then it also shows you the exact values of your current accuracy and theirs. So this is just added to the heads-up display. And you'll see the AI's accuracy is based solely on the user's accuracy with some equations and formulas that I created. So to update the AI's accuracy, I created 3 formulas. And what these do is essentially change the AI's accuracy every time either the user or the AI will respawn. So after they die, the AI's accuracy will change. The AI's accuracy will either increase or decrease, and it will constantly increase or decrease to be closer to the user's accuracy. So in this project, I focused on the accuracy of the user, or the accuracy of the AI, and that's the thing that will continually change. And that's the thing that will adapt to give the user more chance or less chance, depending on how good they are against the enemy. So in these formulas that I created, I have an increment formula, a decrement formula, and a supplemental decrement formula. And in the increment formula, you have the A pre, which is used, it's the AI shooting accuracy before reassigning that variable A, which then becomes AI, or A post, which is the AI shooting accuracy after the reassignment. So in the increment formula, you've got delta over R plus A pre, which is essentially delta is the difference between the users and AI's accuracies, and R is the rate of change, or the speed at which you want the AI's accuracy to change over time. So you take the AI's accuracy and you add it to the difference in the accuracies divided by the rate of change. and then that will become the new AI's accuracy, and that will, using the increment formula, will bump it up, and that's in the condition. So you use that formula in the condition of the user shot accuracy is greater than the AI shot accuracy. So then that will move the AI shot accuracy closer and up closer to the users. And then in the opposite end, if the user's shot accuracy is lower than the AI shot accuracy when the AI dies, then the AI's accuracy will become lower using the decrement formula, which is just subtracting the AI shot accuracy from delta over R. And that will then get the AI shot accuracy closer, but not exactly to. And the last one is a supplemental decrement formula, which is used only in the case when the user dies and respawns. Because in that case, I would assume that the user died, so the AI is probably too difficult for the user at that moment. And so in that case, using the supplemental decrement formula, instead of using A pre in the formula, we're using B, which is the user's shot accuracy. So this makes it so you take the chain, or the difference of the shot accuracy divided by the rate of change, and subtract that from the current user shot accuracy, which will then reassign the AI shot accuracy to be always lower than the user shot accuracy, because you're subtracting it from the user shot accuracy, which is B. So you'll see this. This is the completed project screen capture. This is everything put together. You can see the shot accuracy user interface at the top right. I have the AI just starting with a 10% shot accuracy. That could easily change, but that way he can hit at least some shots, 1 out of 10. And your shot accuracy will go up as you begin to shoot and hit the target. So I'll just begin by trying to get his attention, so I can run over and start shooting him. His health decreases, and my shot accuracy goes up as I hit him. And as he dies, his shot accuracy is increasing. I'll play this a second time because it goes by really quickly. At this point, I'm letting him kill me, so his shot accuracy now goes under mine using the supplemental decrement formula. At this point, I'm now killing him a bunch of times. I've already killed him several times, and his shot accuracy is coming closer and closer to mine. And that's the point of this project, is getting his shot accuracy to be the same as mine. No matter how high or low my shot accuracy is, I want his to come closer and closer to mine over time. So let me just play that one more time so you can see what is happening. Mainly just focus at the top right, what's happening as I hit the user, my shot accuracy goes up, he dies, and how his uses the increment formula to increase continually closer to mine. Now I'm letting him kill me. It's using the decrement formula, or the supplemental decrement formula since he killed me, which puts his shot accuracy under mine since it was above mine before. And then this is just after a while, they just come closer and closer. They start converging. You can also see the line traces. This is sort of a debug mode. You can see like the lasers coming out of the rifle. That's what those are. Anyway, so now just moving on to the last stages, the deviations from the original plan. I did most of what I originally wanted to do along the lines that I wanted to do it for the proposed project. But a couple things that I changed is I ended up just using the line tracing that I was just mentioning instead of using projectiles. It just felt more realistic, and it's less computationally expensive. And then I actually changed how I was going to do the AI accuracy mechanic, which instead of shooting a line trace every time he shot, he actually just uses like a Boolean to whether does he, essentially it's like, did he hit me or did he not hit me? Did he hit me or did he miss? And instead of shooting every single time and just using like a scope of where he shoots in that scope, I just changed it to be using his current accuracy and then creating a random float. If that random float between 0 and 1 is greater than his shot accuracy at that time that he shoots a shot. and if it's lower than, then that means that he basically misses, or he does not shoot a line trace, but it still plays the animation of him shooting. So that's how I changed that. I just made it a little more simple, but still does the exact same thing. And then along the lines, I just added a couple additional features, more than I had originally planned, but it was just sort of to give a better feel in the game, make it more realistic. These are the resources and citations that I used. A lot of the character models, the particle systems, the content, a lot of the tutorials I have listed there. And so that's the end. Are there any questions?
Questions, please.
Right.
So I have one simple question. So
Sure.
adaptive AI and then the AI based game change is broadly applied, right? So in most of the, I mean, some of the game engine companies, they're trying to include this adaptive AI system into their games. So just trying to
Okay.
change
Right.
it, the difficulty levels or maybe some other kind of stuff. So are you planning to, I mean, could you explain what you are planning to do as if it is, if you have some time, as a possible future work?
Oh yeah, absolutely. I guess I should have added that as one of the slides. What I plan on doing with this project in the future is, for this particular project, I just focused on the the shooting accuracy of the user and the AI, which is one of the biggest things because that's how you die, is if they hit you. And so that was basically the first stage of this. But what I want to do in the future is also look at the how he moves around the map based on how the user moves. If they just stand in their position when they shoot, or if they're moving around as they shoot. How much they move around and how they use the movement mechanics. That's something that can adapt over time with the AI as well. And then also, do they use cover? Do they actually use the map? Do they run around, or like based on their health? If they get low health, do they run back around cover to use something to cover themselves up? Those are all types of things that I can add to make the AI adapt, instead of just the AI like you saw in all those screen captures. He just stood there and shot because he's still very basic. I can get him to move around, but not just on his own accord, but based on how the user is moving and how the user is using the map. So that would be the next stage that I would want to do. But there's a lot of elements of how the AI interacts with the user, and you could take each of those elements and slices and program each of those to be based off of the user. This is essentially just showing you can get the AI to change and come closer to how the user is playing. This is just using one example of that. You can take any of those elements and do the exact same thing. So that's something that I would want to do with this project in the future.
Okay, thank you. So any other questions? Right, thank
Alrighty,
you.
great.
So, oh,
Was there a question? No? Okay,
no, I think nobody, no one is asking questions. Okay,
great.
let's
Thank
stop
you.
now and then move on to the next presenter.
Oh, there's I guess someone typed a question. Have you thought about adding random skills and accuracy based on character type for more realistic feel? Um, yeah, I mean that would be adding more to the first-person shooter game that I had created. So, or I guess, oh, random skill. Sorry, I thought you said skills. Um, yeah, I guess depending on the character type, since I only had one opponent, I wasn't focusing on having a variety of different types of accuracies and skills. But yes, if I say this were like a full-fledged game where there were a bunch of different, like say you had a boss fight versus just normal like grunts on the line, then the grunts would probably just not close enough to my shooting accuracy. They would still have a worse shooting accuracy. then like the higher end bosses or the higher end opponents, they would have the accuracies that equaled mine, but all the lower end people, they would have lesser accuracy and lesser skill. So that would just determine or be determined based on how many opponents you had and what types of opponents they were. But yeah, that is something that I could do. Anyway, okay, so that's it. Thank you.